Okay, I'm going to solve the balancing and predicting test. Remember, you can always hit pause to think or rewind, so I'm going to go a little quick here. So the first three are just balancing. Let's pick something to start with. I see 3 lithium here, so that puts a 3 here. That makes 3 bromine, so that puts a 3 here. And I already needed 3 sodium, so I think I'm done. Just double check. Let's pick something out of number 2. 2 fluorine puts a 2 here. And I needed 2 lithium anyway. I think I'm done. 1 calcium each and 1 sulfate group each, and I'm done. Let's pick something that's out of balance on number 3. Hydroxides here. Actually, let's do this bromine first because that is more problematic. 2 here puts a 2 here. That makes 4 hydrogens, which puts a 2 here, and that solved my 2 oxygens anyway. On number 4, it says tin 4 chloride. Tin is SN. It's plus 4. That's what the Roman numeral means. Chloride is -1. Look at your periodic table, so we'll need 4 of those. If you have a chemical that's together, all you can do is rip it apart. So let's rip it apart. And a metal by itself is just charged 0. They're not diatomic or anything, just put SN. But chlorine by itself is diatomic, so it's going to come in pairs there. Then we can balance it. I need 4 chlorine coming out if I've got 4 going in, so 2 goes there, and we're done. Number 5 says calcium hydroxide. Calcium on your periodic table is plus 2. 2 on your ion chart. Hydroxide is -1, so we'll need 2 of those. Plus phosphoric acid. If you look at your acid naming notes, phosphoric acid uses phosphate. Go on the ion chart and look at the bottom. Uses phosphate. On your ion chart, that's PO4 -3. Acid means H, it's an H giver, so it's got to have some H's to give. H's are +1, so we will need 3 of those so that we have +3 to balance a -3. We have an acid and a base, classic hydroxy base. What you'll get is water and a salt. A salt is any plus-minus pair. You get, doesn't matter which one you write first, you get water and what's the salt? It's the calcium with the phosphate. Calcium is +2, we just said, and phosphate is -3. We're going to have to make these meet at the lowest common multiple, which is 6, so I'll have 3 of these and 2 of those. That makes it -6 and +6, and now I have it adding to 0 like it should be. Now we have to balance it left and right. Let's pick something that's out of balance and not the hydrogens. Let's probably save those for last. 2 phosphate puts a 2 here. 3 calcium puts a 3 here. And now how many hydrogens do I have on the left? 2 times 3 is 6. 2 times 3 is 6. I have 12 total on the left, so I need 12 total on the right. That puts a 6 here because my hydrogen is coming in pairs in the water. Number 6 says magnesium iodide. Magnesium on your periodic table is +2. Iodide means just iodine with no extra oxygens or sulfurs or anything. And that's -1, which means I need 2 of those to make that add to 0. And chlorine. And as we just discussed, chlorine by itself is diatomic, so it comes in pairs. So what could happen here? Well, the chlorine does like to be -1, so it could replace this negative here and grab onto the positive. So let's do that. Mg, we said is +2, and chlorine, when it's an ion, is -1. So again, we'll need 2 of those. And iodine, when it comes off, and it's by itself, is also in our diatomic group, so it's in pairs. Actually, that self-balances, and we're done already. 7 says barium nitrate. Barium is +2. Look at your periodic table. Nitrate is on your ion chart as a -1, so we'll need 2 of those to make that add to 0. Sodium phosphate. Sodium is +1 on your periodic table, and phosphate, as we said before, is on your ion chart is -3. So this doesn't add to 0 until I put a 3 there. So let's trade the partners. The barium could get a new partner, but of course it can't have positive on positive. It would get a new negative, and that's the only other negative on offer. So barium with a +2 could go with phosphate. That's a -3. Again, the lowest common multiple of 2 and 3 is 6. So we'll have 3 of those and 2 of that. And I've got to have parentheses because it's a group. Now we have +6 and -6. The other pair that could be formed is the sodium with the nitrate. Sodium is a +1, nitrate is a -1, so that already works. And for all the kids saying, but there were 2 of the nitrates, I know, but does +1, -1 already work? Does it already add to 0? The answer is yes, so quit fixing it when it's fixed. We'll deal with the fact that there are 2 of these in a minute, like right now. 2 of them go in, 2 nitrate sets had better come out, so that's a 2 there. That makes 2 sodium. Oh, we have a bit of a problem, and remember, sometimes you have to erase, even if you're doing it right. Even I have to erase sometimes. I get caught, because now I have 3 sodium and 2 sodium, and that can't happen. So let's go back and double everything we just did, including putting 2 there. let's say that's 6, and this is 2, because that is 2 times 3 is 6. And that makes 6 nitrate, so I got to have 6 nitrate. Currently I have 2, so I'll put a 3 here. And you know what that did? I was right to go back and erase and double, because that made me put a 3 barium here, and I already needed 3 there. So I fixed barium by accident, which is a very good sign. Let's get some room and do the rest. 8. It says manganese 3, manganese, not magnesium, plus 3, oxide. With oxygen, just oxygen, no other things. It's not hydroxide, it's oxide. So that's a -2. Look at your periodic table. Again, lowest common multiple is 6, so we'll have 3 of this and 2 of that. Now we have +6 and -6. And if you had to have just one chemical, all you could do is rip it apart. So let's rip it apart and say manganese. And remember, a metal by itself is just the metal. There's no such thing as a diatomic or triatomic or anything metal. And oxygen. Let's rip the oxygens off. But when oxygen is by itself, it is diatomic, so we have O2. Now, some of you have already spotted we have a 3-2 problem here. And again, least common multiple is 6. So we'll have 3 of these. Oops. And 2 of those. Now I have 6 oxygens going in and 6 coming out. And now I have 4 manganese going in, so 4 had better come out. 9, I did say it was combustion. So C6H10O3. Combustion means combined with oxygen. So let's set it on fire with oxygen in the air. And what will it make? And I do expect you to remember this. It's not that much to remember. It's carbon dioxide and water. In any order, you can put the water first if you want to. So often these are kind of difficult and you have to end up erasing. So let's just see what we get, because I'm really doing this live. I don't remember the answer, just so I make sure I explain everything. This 6 makes me want to put a 6 here. And 10 makes me put a 5 here. You know what we know we have? We do not have an even odd problem, because how many oxygens do we have? 6 times 2 is 12, plus 5 is 17, which is an odd number, but so is the left. The left is also odd, so we don't necessarily have to go through and double everything. Let's see if we can get away with not doing that. This 6 put a 6 here, this 10 put a 5 here, so 5 times 2 is 10. Again, how many oxygens do we have on the right, 12 and 5 is 17. So I need the left side to be 17, but 3 of them are here. Of the 17 I need, 3 of them are here, which means I need 14 more, and 7 times 2 is 14. Combustion with C2H5O. Combustion combines with oxygen in the air and makes carbon dioxide and water. This carbon makes me want to put a 2 here. The 2 carbons makes me put a 2 here. And this 5, well, that can't actually work, can it? Because this cannot turn into 5, because an even number cannot multiply to be 5, or any odd number. So we are going to have to go back and erase and double. Let's put a 2 here and see if that fixes everything. That puts a 4 here. And that makes 10 hydrogen, which puts a 5 here. And looking at this, I think we are going to have a double erasure problem, because this is even, and this is even, this is even, and this is odd for oxygen. So we do have an even, odd problem with oxygen. Let's go back and double everything again. How many do we have now? I have 8 carbon, just confirming I did that right. This is 20 hydrogen, and this is 20 hydrogen. Good. So how many oxygen are on the right? Because I hope I've got the right side locked in now. This is 16 and 10 is 26, and I need 26 on the left. But 4 of them are here. 4 of the 26, excuse me. Leaving 22 needed, and 11 times 2 is 22.